So this is about given values in probability distributions. So we're still not time-based. We have multiple outcomes, but last time our uniform distribution, because it was a uniform distribution because everything was equal. This time, our probability is varying. So think back to the addition and multiplication rules of probability. With multiplication, we're done with multiple outcomes, and their probability changes depending on if we replace it or don't replace it. So the example we're going to talk about is the Colorado lottery. So you pick 6 numbers out of 42. So let's look at what they say all of these probabilities are. So when you go to their website, for the 624 game odds, to get 6 out of 6, you have that many chances, 1 out of that many, which is crazy. You can also match 5 out of 6, 4 out of 6, or 3 out of 6 and still get some money as we go through, and you'll notice the overall odds of winning any prize are 1 out of 35. But focus on that number right there. How do they even come close to going about that number? There's only 42 choices that you get to pick from, and you get to pick 6 of them. So to match 6 out of 6, how do we get to that point? Well, let's check it out. So there's a really awesome function in Excel that's going to take these 42 options, choose 6 of them, and then tell you the total number of choices that could happen, the total number of outcomes that could happen. And you have to understand, this is not just every combination of 6. This takes into account if I choose a 1, then that number is gone. What are my next choices if I choose a 1? What are my next choices if I don't choose a 1? And then if I do choose a 1, then what are my next choices if I choose a 2 or I don't choose a 2? And so you have this huge chart that ends up being. This will tell us how many total choices there are. So comb in, and then you get to say what are your total choices, in this case 42, and we are going to choose 6 of them. Oh look, that's the same number that we saw. So the probability of winning is 1. You match all 6, that's your choice, divided by the total number of possible outcomes, which is that number. So we're going to say equals 1 divided by that number, and that is your probability of winning. That's kind of painful. So let's look at the probability of winning and not winning in a little different way. So we have 2 outcomes if we want to go at a different level. So what's the probability that you win the big prize or that you don't win the big prize? So you can either win one person wins. The people who don't win are that many minus the 1 choice, 1 option that does win. So our probability is going to be that number, again, the number of things that meet our requirement that you win, divided by the total number of options. Here we can talk about the number of options that meet, number of outcomes that meet our criteria, we don't win, divided by the total number. And again, we could of course subtract this by 1 or subtract this by 1, and we have both of them. So this is one easy way to use given values of things that change.